Somewhere in the United States, an electric vehicle battery plant that once ran below capacity is being retooled. Not for cars, but for batteries that can sit beside AI data centers and store power for the machines driving one of the world's most capital-intensive technology races. That shift captures something larger. The AI boom is no longer just a story about one chip, one model, or one company. It is now a story about capital, geography, timing, and power, moving through Asia's technology stack all at once. The first signal is at the competitive layer, where pressure is most visible. DeepSeek, the Chinese AI startup, appears to have built a meaningful position against US frontier labs, such as OpenAI and Anthropic, not by outspending them, but by undercutting them. It has reportedly taken more than 30% share on global developer platforms, such as OpenRouter, raised $7.4 billion, and distributed open-source models at much lower prices. That matters because it suggests the AI contest may not be decided only by who has the most advanced chips or the strongest frontier branding. For price-sensitive developers, especially across Asia, efficiency and distribution may matter almost as much as peak capability. In other words, one of the clearest early pressures in AI is on pricing and adoption, not only on technical prestige, but cheaper models do not remove the need for advanced hardware. They change where value may concentrate. That brings us to the equipment layer, where ASML remains the critical choke point for leading-edge chip production. In the second quarter of 2026, ASML reported 9.3 billion euros in net sales and 2.9 billion euros in net income, then lifted full-year revenue guidance to 43 billion to 45 billion euros, with expected gross margins of 54% to 56%. It was the company's second upward revision of the year, and it linked that strength directly to AI-driven demand. The message is straightforward. Even if competition in models becomes more cost-sensitive, the physical infrastructure behind advanced AI chips remains scarce, expensive, and heavily demanded. Pressure may be building on software pricing, but at the equipment layer, the market still looks tight. That tightening is also changing geography. TSMC, the dominant advanced foundry, is expanding far beyond Taiwan. The U.S. Department of Commerce and the White House said TSMC will add $100 billion to its Arizona investment, bringing its total announced U.S. commitment to $265 billion. The expansion includes 4 additional advanced semiconductor facilities, raising the planned U.S. footprint to 12 leading-edge logic and packaging plants. This is not just another capacity update. It suggests that AI-era chip production is now being treated as strategic infrastructure, something governments and companies are willing to duplicate at very high cost in order to reduce geographic concentration. Taiwan remains central to advanced manufacturing, but the map of where that manufacturing happens is starting to shift. Still, owning the newest tools is not the same as deploying them profitably, and Samsung's recent posture makes that distinction clear. Samsung Electronics has installed 2 High-NA EUV lithography systems, the newest generation of extreme ultraviolet tools designed to print the smallest and most complex chip features. Yet the company is deliberately holding back from moving those systems into mass production. According to the source, that caution is meant to limit depreciation expense and fixed overhead, while Samsung's foundry division works toward a return to profitability by the fourth quarter of 2026. This is a useful signal because it shows that the leading-edge race is no longer only about getting the newest machine first. It is about matching that investment to real customer demand, utilization, and balance sheet pressure. Frontier technology that cannot be deployed at the right time can become a financial burden rather than an operating advantage. If Samsung shows caution at the company level, India's Semicon 2.0 program shows ambition at the national level. India's Union Cabinet has approved a program worth roughly 127,500 crore, or about $15.3 billion, aimed at strengthening semiconductor design, materials, machinery, and manufacturing capability across the country. Unlike earlier efforts that focused more narrowly on attracting individual fabrication projects, this program is structured to support a broader ecosystem across several layers of the value chain at once. The intent is clear. India wants to move higher in the semiconductor hierarchy, not simply host isolated plants. But approval is not the same as execution. Whether this becomes durable industrial capacity will depend on follow-through, private sector response, and the ability to translate policy into a functioning ecosystem. The final signal moves away from chips and into power. LG Energy Solution, the South Korean battery maker, is converting part of an idled U.S. electric vehicle battery plant into a production line for LFP battery cells for energy storage systems. According to the source, the shift is tied to rising demand from AI data centers, which need substantial backup power and storage to operate reliably at scale. This is better seen as an early signal than as proof of a broad industry pivot. But it still shows something important. AI infrastructure demand is beginning to spill beyond compute and networking into adjacent industrial capacity, including assets that were originally built for a different market. Taken together, these 6 signals should not be read as a simple chain of cause and effect. They are parallel pressures across different layers of the same system. Model providers are pushing prices down. Equipment suppliers are seeing sustained demand for advanced tools. TSMC is expanding strategic capacity in the United States. Samsung is managing the financial cost of frontier deployment. India is trying to build a wider semiconductor ecosystem. And LG Energy Solution is redirecting battery capacity toward AI-linked storage demand. The common thread is infrastructure realism. Capacity has to be financed, located, supplied, powered, and used efficiently, not just announced. For investors, the practical lesson is to follow AI through the full stack, rather than through a single proxy. Watch DeepSeek for pricing pressure and adoption behavior. Watch ASML for the health of demand at the equipment bottleneck. Watch TSMC's Arizona build-out for signs of geopolitical diversification and strategic capacity. Watch Samsung for evidence that utilization and capital discipline still govern the leading edge. Watch India's Semicon 2.0 for implementation and private capital response. And watch LG Energy Solution for whether AI-linked storage becomes a real adjacent market. The opportunity now spans the entire stack, but so do the risks. Timing, execution, profitability, policy durability, and the quality of underlying demand.